All right, so let's continue on with the law of sines. So unfortunately, not every triangle is possible to be solved with the law of sines. And so we'll see some of those in the next section when we do the law of cosines. The side, side, side case won't work. If you have all three sides, you don't have an angle, you don't have a pair. There's no way to set up those fractions to be able to solve. So can't do that one. You can't do the angle, angle, angle case. In fact, you can never do that one because if all you have is three angles, similar triangles, they could be any size you want. Let's see, there's one other one. What else can we do? Side, angle, side. Can't do that one where you have two sides and the angle in between because, again, you don't get a pair out of that. Okay, now we are going to look at one more case, and I'm going to do two examples for it. I've got one on the board now. We'll see one in just a minute. The side, side angle case. And this one's nasty, or it can be nasty. So you have to really watch out for it. Easy to remember the way that, hot way to remember that this is the one that's nasty. Just turn the letters around. You'll get it. It'll be obvious. All right, so side, side angle case. So here's what we have. I have two sides and an angle, but notice that my angle is not in between those two sides. It is, so I actually do have a pair. I have a capital A and a little a here. I have side C, but what I don't know is I don't know side B. And even though I have this side A, I don't know where it's actually, which direction it is hanging down there. Okay, so that's why I have a question mark here. Side A could be off over here to the right, it could be over to the left. I mean, there are possibilities. We don't know where that side is. It's just kind of hanging there, and we don't know where it's going. So if you think about a triangle as having a height, we can come up with 4 different possibilities for the side-side angle case, and that sounds like fun, doesn't it? So the first one is actually really nice. If your dangling side is shorter than the height of the triangle, guess what? You don't actually have a triangle. So to kind of put it in perspective, and actually we're going to see it right there in just a second, this side, if you let it just dangle straight down, it wouldn't reach the bottom. So there is no triangle there. If A is equal to H, if this side, dangling side and the height of the triangle are the same, you'll get one triangle and it's a right triangle. And so guess what? We're not going to be terribly interested in that one because we're not doing right triangles right now. So case 3 is going to be the messy one. If this dangling side is between the lengths of the other side that we know and the height, you're going to get 2 different possible triangles. And we'll see that case here when I clear the board off and do my last example. And then finally, case 4, if side A is bigger than C, that's a nice one. It'll be just like the other ones that you'll find. There's only going to be 1 triangle. So really, it's just this third case that is nasty. But first, let's take a look at an example of one that ends up being the first case. And I have that over here. So I have my triangle. You'll notice I have 2 sides. This would be, I don't know, side B, I guess. Or let's call it C, so it matches the other triangle. And this would be side A. So notice side A here is just kind of dangling there. Again, we don't know what direction it's going. Now I've made the bottom of this triangle a dotted line because I know the size of this angle, so I know where that side has to be, but I don't know how long it is. Okay, so I made it a dotted line. It's going to go somewhere out here. You'll also notice I sketched in the height of my triangle. I'm going to use the height to try and establish which of the 4 cases I'm actually looking at. So the way I do that is to say, hey, look, this is just a right triangle with A and then my right angle here. So the sine of 42 degrees has to equal that ratio, the opposite over the hypotenuse, h over 18. I can solve that. All we have to do, multiply both sides by 18, and if you do 18 times the sine of 42, making sure that you are in degrees, you get 12.04, which is a really beautiful number, but 12.04 is ever so slightly bigger than this dangling side. This dangling side will not reach the bottom of the triangle, so we have no triangles. So that's a really nice case because you go, hey, look, here's my height. I'm done. I don't have any triangles, won't work. And now we'll go explore the harder one. All right, so let's finish up with a nastier example. I'm going to leave you guys to finish the problem, but I'll get you through all the really nitty-gritty weird stuff. So here's our setup. We have this triangle. We have angle B this time, and we have the side opposite. So capital B, the angle is 32 degrees, the side is 9, and then we have a side C here that's 14. So again, you'll see I drew my side along the bottom. I know where it goes, I just don't know how long it is. So I made it dotted, and I filled in the height. So just like on the last example that we did, I'm going to try and find the height of this triangle to see what case I'm in. So the sine of 32 degrees has to be the opposite over the hypotenuse, so h over 14. Multiply both sides by 14, and you get that h is equal to 7.4. Again, making sure your calculator is in degrees. Now, unfortunately, 9, my dangling side, is in between the height, 7.4, and this other side of 14. So this is where I know I have two triangles. This is that third case that we were looking at on the last whiteboard. So triangle 1. All right, we're just going to jump in, and we're going to do this like we would do the law of sines anytime. Okay, so the first triangle isn't bad. The second triangle is one that people always forget. So that's why you go through this process of saying, oh, look, this is a side-side angle triangle. I need to find that height so I know how many triangles I'm actually looking for, because I don't know. I mean, I think I know the guy who wrote your test, and I'm pretty sure he's mean enough to put something like this on there. So pay attention. All right, so anyway, we start with the law of sines. I have both parts for B, so I do the 9 over the sine of 32, and I'm going to go looking for angle C first because I don't have either one of the A's yet. So if I do that, I cross multiply, we get 9 times the sine of C is equal to 14 times the sine of 32. Divide both sides by 9. Now that gives you some nasty looking decimal, and then we're going to use inverse trig. We're going to use the inverse sine inverse here, sine inverse, to get that 55 degrees out. Okay, so we type all that into our calculator, we get an answer, and then we do the sine inverse of that, and if you do, you get 55 degrees. So now that gives us this angle, and it's probably right about there. Down here on this triangle, we have angle C. Once we have two angles, we can find the third angle just by subtracting again. So 180 minus 55 minus 32. Those are the two angles that I had, and that's equal to 93. And that just leaves side A down here on the bottom. I'm going to leave that to you. It's very similar to the law of sines problem that we did earlier. So go ahead and find side A there. But what I really want to look at here is how do we get from this first triangle into the second triangle? And so it turns out that the second angle C is always the supplement for the first one. And so we can prove that. I'm not going to do it right now, but it is provable. I think your book probably has that in there. But so to get to the second triangle, once you find that angle, so this would be this angle down here, this other one is going to be the supplement for it. And so if you imagine the side dangling this way. So 180 minus 55 gives me 125. I can find that third angle again by subtracting 180 minus 125 minus 32. This time I get 23 degrees. And again, we are still left then trying to find that little side A. But so anytime you have the two-case possibility for side-side angle, once you find that angle, and because that's going to be where you're going to start it, you're going to find that angle first. The second one, for the second triangle that I have down here, it's always going to be 180 minus that angle that you found. And so there we go. That'll be fun. You guys will really enjoy this. And yeah, good luck.